So let's go and get started. If you have any questions, feel free to chat. Tim Cockrell's here. He's one of the directors here at TAC. More than willing to answer your questions throughout this webinar. A few other TACsters on as well. First, as we get started here, let me tell you a little bit about DesignSafe. All right. So DesignSafe is our cyber infrastructure that we have developing here at TAC. Its vision is that we want this CI to be an integral part of your research work cycle, your discovery place. What we want this to really be is a place to support your end-to-end research, from conceptualizing of an idea to publishing an idea to then taking that publication and having it spawn off a lot of new ideas, and then those new ideas become more publications and more research and innovative ideas that keep the cycle going. Essentially what we're doing is we're providing you a portal. That portal has a lot of cloud-based tools in it, and that we're going to be talking about some of those tools today. So these tools support everything from data analysis to visualization. We want to be able to integrate a diverse group of data types that you have. So basically the idea is we don't want you to conform to our standards. We want us to conform to whatever work cycle works best for you. And that is what the goal of DesignSafe is we are designing this around you, the researcher, you, the scientist, you, the engineer, and build our system to adapt to your workflow. And then, of course, we want to be able to enhance, amplify, and link the capabilities of other NHERI components and serve the natural hazard community, which is basically you guys out there. So how are we doing this? So we're doing this through basically four different steps. We have our simulation research, we have our experimental research, and we have our rapid research. All these guys are essentially producing a lot of data, all right? We want all that data to come into DesignSafe and being housed there, essentially housed on the cloud for you. Housed with what we call the data depot. Now the data depot will then be able to publish that data. You get a DOI link to it. And you can do all of your analysis work on the CI as well. And we'll give you a bunch of other cute little tools so you can actually connect to your Dropbox, connect to your Box account to be able to easily upload data easier, manage your data easier. But once again, everything, once it gets on the cloud, it can stay on the cloud, and essentially all your research tools are going to be there for you. So that is our goal, and that is what we're making strides towards hitting. And we're making large strides. We're almost having releases at least once a month, or new releases, new updates. So with that in mind, we're going to use DesignSafe today, and we're essentially going to show you how to best using DesignSafe with Jupyter, which is a interactive cloud-based IDE, or in a design environment for you, and the programming language R. All right, so this is the stuff we have planned today. I'm going to introduce you guys to Slack. So one of the things we're trying to do with DesignSafe is we want you to collaborate more. We want you to come together as a community, work together on research projects, share data models, share data, ask questions. And one of the best tools out there right now to do that is this tool called Slack. So we're going to introduce Slack to you. We'll do a little walkthrough. You guys should all have an invite to the DesignSafe Slack team. So feel free to connect to that, and we'll share the slides from today's presentation and share our data and the notebooks that we create. All right, then we're going to introduce what the Jupyter Notebook's about, how it works, some of the shortcuts, and exactly how to set a notebook up. Then we're going to discuss the basics of R. So a lot of R's are it's not relatively new. It's been around for quite a while, but it's underutilized. So we'll show you some of the characteristics of R, how it works, what the syntax of it is, and then play with data frames, which is what R uses to be able to load your data sets in. And we'll show some basic plotting, and then we'll show you how to do some data analysis with this plotting package called ggplot2. And that really should round us out for the day. Okay, so essentially what's Slack? So in a nutshell, Slack is a communication tool, all right? But it's a little bit more than that, and we'll talk about what those little bit mores are. But some of the lingo that's kind of common in Slack is we have teams. So essentially, anybody can create a team. It's essentially creating a URL that your Slack client connects to. In these teams, you have channels. So these channels you can kind of think of as general topics of discussion. Anybody can create a channel. In fact, you can even create a private channel and you can actually talk to other people. You can also create a private channel with just yourself. And it's one of the rare places where you can actually talk to yourself and people won't look at you funny. But I use that all the time because I put little notices, reminder notes, things like that. Or if I'm in a meeting and I'm just taking some notes real quick, I'll put those in my private Slack channel and then later go and put those, organize them a little bit better. And then the newest thing that Slack has is called threads. Now, threads are essentially, you can take a conversation that's happening in a group and have a more specific topic or a more specific conversation with just a few amount of people. And if you wish to, then you could publish those conversations back out to the main channel. So the best way to get to use Slack, Slack does have a Windows interface or a web interface to it. But the best way to use it is actually downloading the application because you have a lot more features that you can take advantage of. Plus, you can put Slack on your smartphone and you'll get notifications, updates on channels when somebody's trying to talk with you. You can keep certain topics and highlight them so when they come up. So I'm going to jump onto our Slack channel. So when you first come into Slack, it's going to ask you what team you'd like to connect to. This is the URL you're going to be connecting, DesignSafe-CI.slack.com. Once you sign in, username, password, you come across basically this general layout. So you have your channels, you have any direct messages that have gone to you. These are only some suggested channels that it asks you to join. If you click on channels directly, you'll get a list of all the channels that are currently on our Slack. And like I said, you're welcome to create more channels if you need to. So the first thing I'm actually going to do is create a new channel. And this is going to be for our webinar today. So I'm going to call this our webinar. And this is going to be today's date, which is the 29th. Yes, the 29th. Oh, 29/2017. Purpose is going to be to discussion. Further discussions from our webinar held on March 29th, 2017. And I'm going to go ahead and create this channel. And it gives you a little bit of info on it. And go and click got ya. And so now the channel's here. I would recommend everybody who's on Zoom to go ahead and jump onto the Slack channel. It's hashtag R_webinar 03/29/2017. If you have any questions after the webinar is done, we can then discuss these on the channel. I keep track of I actually watch all the webinar channels and the training channel and the Jupyter channel rather closely. So if you have any questions regarding any of those topics, if you go on there, some of us, our taxsters here, will be monitoring those and answering questions and whatnot. Or feel free to send me a direct message here as well. Okay, so some of the cool things you can do on Slack is, all right, so like I said, it's more than just a communication tool. So it's more than me just sending a message out to people and people sending messages back. I can also do reminders. So I can say, remind me in 10 minutes to start this webinar. And it'll go and say, hey, I'll remind you to start this webinar in 10 minutes. And so in 10 minutes, that's going to be 1:21 p.m. and we'll be ready to go. I can see what the other reminders are in there, or I can hit cancel. I do like the way that this actually parses things out. So it's almost common English. Remind me when, or remind me in, and whatnot. We can also do to-do lists. So to-do lists are really nice. So you do hashtag or a slash to-do, and then what the task is, has to do is, follow up with registrants in registrants from our webinar in 1 week. And now it's going to give me a to-do list. And as soon as it puts that to-do list in there, if you notice, April 5th, that's 1 week from today. And it puts everything to me. And I can say, yeah, assign that to me. And now it's on my to-do list. And if I ever look for my to-do list, it'll show me everything, all the tasks that I have set up. Beauty of it is you can also star messages. So if I'm getting a message from somebody, I could look at one of these old ones. I could hit star. And now once I star that message, it's always, I can star it so it can be follow-up, so I can easily search for it. Also, it does the searches are really nice too. So it does a team-wide search. So I can search for anything I want. I can search for Jupyter, and it will give me all the listings where conversations have Jupyter inside of them. You can also narrow that down to be from specific people or to specific people or even a specific date. So the search is actually really nice. And of course, like I said, it's nothing if it's not a little bit of fun as well. There's also animated GIFs. So I can do Giphy, and I can say, hello world. And it will come up with a hello world GIF for me. And you can hit shuffle and whatnot and then post it if you like. So these are just some of the fun points of Slack, but Slack is also a great tool to do our research on, to communicate with the rest of our team, to discuss events coming up, events past, what things need to be adjusted, what things to be looked at. You can also share files. So the one thing I'm going to do now is I'm going to share my slides. So to do that, I can just pull up my Finder app, and it's going to be on my desktop. DesignSafe Webinars, DesignSafe Unleashed. I'm going to go ahead and put that into Slack. And it's going to say, hey, do I want to update? I want to put this on. And I'm going to say yes, and give it a comment. These are slides from presentation from webinar. And go and click upload. And they're uploaded. Also, what I'm going to do here as well is I'm going to pin. So now this has been pinned to this channel. So whenever you join it, you'll be able to find my slides right there and then. Also, if you go to channel information, so if I look at view channel details, you'll have the pinned items right there and for you to download. And we're going to be messing with some data files as well. So I'm going to put those data files on our Slack channel, and so you can download them from there as well. All right. The next thing I kind of would like you guys to do is we're going to be messing with Jupyter Notebooks. Before we go into the Jupyter Notebooks, I would like you to go to DesignSafe. And in DesignSafe, there is a tab called Learning Center. All right, so if you go to Learning Center and go down to Training Resources, inside the Training Resources, there is should be our archive training materials. So if you click on that, we should have we want this CSV file. So go ahead and download this CSV file now. And so I'm going to go ahead and download this. Unfortunately, this is already on this machine. But for you guys, go ahead and download it, because we're going to actually do some stuff in R. We're going to look at that data file and see if we can figure out what it is and what's pertinent in there. All right. Next thing, and before we go in there, the next thing I'm going to just do is a quick little drive-by in DesignSafe as well. So DesignSafe has some, where I was telling you about the data depot, I was telling you about the data discovery, the data workbench, or our workspace. So first thing we're going to do is we're going to go to the data depot. And just to give you a little heads up what the data depot is, this is essentially your file space. So all of my files right here in here, you're going to see your own files in there. And basically all the files, this acts just like a file manager does. All your data files are here. You can view the metadata on it. You can see what the information is on it. I'm going to go and click on details on one of these notebooks, and it's going to come up with a little preview of the notebook. I can look at the metadata. I can see when it was created. I don't think I have any metadata in here, but I can go ahead and put some metadata tags there, so I can search on it at a later time. And I can also share these files with other people. All I need to do is go ahead and put in their DesignSafe user ID and what permission level I'd like to share that with. Okay, so now that we have the data depot open, that data file that I had you guys download, I'm gonna have you upload that into your My Data directory inside of DesignSafe, and then we're going to start using that in Jupyter. So to do that, click on Add, and we're going to go ahead and say File Upload, and we're going to go ahead and choose File. And mine came into downloads here, Training Data 1. And I'm going to go and open that. And I'm going to go and click on Begin Upload. And once the upload, the way the cloud system works is once you trigger a job, essentially what it's doing is it's launching an application, a service in the background that's actually going to upload that file for you. When that, and that gets added to the queue. So when that job gets executed and the file gets uploaded, you get a notification that says, hey, this data depot file's been uploaded, and now it's sitting inside your My Data. All right, so this, like I said, this My Data area, this is your space. The other thing I just want to walk you through real quick is our Discovery Workspace. So if we're going to click on that, this is essentially where all the applications stay. So you can launch your different applications. The application we're going to launch is our Jupyter Notebook. So one of these, and you can scroll over, you'll see Jupyter. So we're going to select Jupyter over here. Jupyter is also available in the menu, in our drop-down menu. So I'm going to go and click on Jupyter, and I'm going to go ahead and click on Launch. First thing it's going to ask you to do is ask you to log in. Essentially what it's doing is so what we use on DesignSafe is called Jupyter Hub. What Jupyter Hub essentially does, it acts as a proxy. When you log in, it goes ahead and launches it creates a workspace for you on our cluster, and it launches that workspace for you to use, all right? And it logs into that machine as the Jupyter user, but it's in your workspace. So your data files will show up in there. So I'm going to go and click on Login here, put in my username and password. And you will probably have a button that says Start My Server. My server's already been started, so I have a Stop My Server button. I'm going to go and click on My Server, and it'll bring it up. Now, this is essentially the root directory of that image that got launched that is private to you, okay? So what you need to do before you even start to create a notebook is you need to go into the My Data location. So click on My Data. This is the exact same My Data as it is in DesignSafe. So if I go here to my workspace, and I'm going to go back to the data depot, all these files here, which are going to be listed, all these files here listed are the exact same file listed here, all right? So if any modifications you make on one gets modified on the other, it's the exact same file system. So now, I just got the reminder from Slack. It's been 10 minutes. Okay. So from here, we're going to go ahead and create a new notebook, but let's understand what these notebooks are. All right, so the notebooks, they're a web-based interactive computing tool. All right, it's a very simple tool. It's a really simple IDE, but the idea is it's really powerful enough that it can essentially capture the entire programming process. All right, you can do your developing, you can do your documenting, and you can execute the code. And then, of course, you can share all the results with other people. Even you share the whole notebook with other people. So one of the things that we do with it is we have to have an understanding how they work. So, you know, we kind of talked about how this works exactly. Notebook has one interactive session connected to a kernel, all right? So the kernels are essentially in different languages. We have the Python kernel and the R kernel loaded currently, and I think there's a bash kernel too. And the kernel essentially remains active while the browser windows open, and actually stays active even if it's closed, because the server is actually still running. So if I click here to, you know, I just logged in, I click here on running. These are all the notebooks I currently have going on. And I think they'll actually show if they're running here or not. So essentially, when you're done with your Jupyter notebook and you exit out, if I close out this browser, those notebooks are still running. So it's a good idea to maybe stop those notebooks when you're done, and we'll talk about how that works. Okay, so notebooks are essentially what we kind of discovered that there's a kernel running in the background. The kernel essentially gives us a programming language that our notebook interfaces with. So we have our notebook, we have our kernel in the background, we have our notebook sitting in front of it. That's where essentially where we interact with our kernel, okay? So how are these notebooks structured? Well, so let's talk about this, and then we'll actually see it in action. So your notebook really has two parts to it, okay? There's a coding cell. This is where all of your code goes. This is where your source code goes, what you execute, what you run. And then there's the markdown cell. The markdown cell is essentially where you document your code. So most programmers out there, you know, me included on that, is we don't document our code very well at all. This essentially gives us a very easy tool to do that. So we can essentially say what each section of our notebook actually does, and then we actually have the code that does it. What's beauty of this is it gives you a really nice structure as well. So essentially what we're doing is we're creating a scientific document that has our entire programming process in, or holds our entire programming process. So we have code cells and we have markdown cells. The markdown cells are really simple. This is just, you know, markdown is a very simple structure. You can add headings with just hashtag space heading. Actually, let me go ahead and create a new notebook here real quick, and we will do that real quick. All right, so I'm going to create a new R notebook. First thing it comes up, by the way, if you notice, it's untitled, so it's always good to give it a title. So I'm going to say intro to R, and today's date, 03/29/2017. All right. So first thing we see is our input cell. So we can do anything we want here. I'm going to go ahead and say command, hashtag. Oops, I'm sorry. I'm going to change this to a markdown cell, and I'm going to put hashtag just heading 1. All right. And if I hit Shift Enter, that'll go and execute and give me a heading. So we can do headings. We can add lists. Lists are actually either an ordered list or a non-ordered list just by your starting number of things. Also, markdown cells can have pure HTML inside there. So I can do stuff like, let's go ahead and go back to our markdown. And I can do something like bold. Testing. And I could write the word testing and make it in bold. We can also, of course, do any kind of HTML like lists. You can have links, you can have anchor tags, you have paragraph tags, anything you would normally do in an HTML page, you can do here. And of course, a lot of people like this functionality is it can do latex. I'm going to make that into another markdown cell. And we can do something like $sign E to the power, say, pi. Oops. I don't want that to be a parenthesis. I want that to be a squiggly bracket. +1 = 0 and end. And it gives me a cute little equation. So we can handle LaTeX. So that's really nice about these notebooks, is it gives you a lot of versatility. And the idea is, what we really want these things to do is you want to be able to solve a problem, a computational problem, usually something math-oriented. So you want to be able to put down as much detail about what it is you're trying to solve, what it is you're trying to program, and be able to communicate that to other people that you're sharing this thing with. All right. So essentially what you're doing is when you work on any computational problem, you're working on it in pieces. And so that's kind of why they have this cell structure in there. Essentially, you're organizing your cell to, you're organizing your related ideas into cells and then moving forward from one cell to another cell, each conveying a different idea to the entire computational program that you're trying to solve. All right, so workflow, how do you want to set this thing up? My suggestion is to make this thing be kind of like a traditional paper lab notebook. So the entire reason laboratories have notebooks in the first place is so they can take your data or your work, your experiment, and replicate the experiment from beginning to end and get your data the same conclusions that you reached. We want to be able to do that with Jupyter notebooks as well, except now we're doing a computational process instead of an experimental process. And so here's some quick little shortcuts. You feel free to read these through. Shift-Enter is the one I always use. Essentially, it executes the current cell and then automatically goes ahead and creates a new one. There's also Control-Enter, so that doesn't create the new one. It just keeps it in place. Alt-Enter goes ahead and inserts below. You know, Escape and Enter, all that fun stuff. Okay. So now that we got kind of the basics of handling and navigating through a Jupyter notebook out of the way, let's go ahead and jump into some R stuff, all right? So for those of you who are new to R, R is a computational language developed for statistical computing and graphics as well. And essentially it began as an experiment using Lisp implementers. If anybody's ever used Lisp, I'm sorry. I've tried to learn Lisp many a times, and yeah, it's one of those coding languages that's very difficult to wrap your head around. R, on the other hand, is actually a really easy programming language to wrap your head around. You know exactly what's going on. Essentially, all it is you're building objects and you're modifying them, okay? So, which is why it's great for data, because you're building an object with data in it, and then you're modifying it somehow. All right, so R is very effective at data handling and storage facilitating, all right? It gives you really a big, huge suite of operators for calculations on arrays, matrices, you know, and has a bunch of collection of data analysis tools. It's got a really cool basic graphic engine, which just gives you part of the story, and then you can use other libraries, like what we're gonna use today is ggplot2, to get a little bit more of that story out. And once again, it's really simple. It's kind of cool that your C and C++ Fortran code can be linked into it. And actually, advanced users, you can write your C code to manipulate R objects directly, which is kind of slick as well. Okay, so essentially, we're going to get jumping in right away. So there are 3 types of classes, or 3 basic types of data objects. In R, you have numerics, characters, and logicals. And if you remember, most programming languages are kind of set up the same way, though there's a few odd ones that really don't give that to you. But R is going to have all your basics, and we're going to see them. You have your data types, which is what we're kind of looking at right now. You have conditionals. You have your control structures, conditionals and loops. And then you have your arrays and matrices, all right? And then R gives you all the cool little statistical command stuff. So let's gonna run through the syntax real quick. We're going to then look at that data file, figure out how to upload that into our notebook, and play with that, play from there. All right, first, so the syntax in R is really easy. Everything is essentially an object, and it's not typed at all from the beginning. So if I want to create a numeric, I'm going to call it n, you know, I can basically put the number 42 into n. So I can do that. If I hit Shift-Enter, it's going to run, and now I have this guide called n out there. So if I just hit n by itself and hit Shift-Enter, it's going to go and tell me what's inside of n, 42. We can also do cool little stuff. We can do, math functions as well. So I have a little example there. Can do equal to, by the way, should say equal to, or the arrow, both work the same way. Both are equivalent functions. So I can do, square root of, 2. Yeah, I can print out h, and it'll tell me what the square root of 2 is. Arrow commands are really cool to just navigate from one cell to another. So if I do something like this and say -2, it's going to give me a message saying, hey, an NaN was produced, essentially saying not a number. One of the cool things about programming languages is I always try and teach my students is mess around with it. You're going to see errors. Errors are good because the more errors you see, the more errors you understand what those errors mean. If you coded perfectly from day one, and then all of a sudden you wrote something and you got an error, you have no idea what that would mean or how to fix it. But if you make errors while you're coding, you're going to understand them better. You're going to be able to recognize them, and you'll be able to shoot to exactly what the problem is, because usually error messages don't make much sense. So it's good to know what causes them and what they look like. All right, so numerics in a nutshell. Characters essentially work the same way. I can do a hello world real quick. That, of course, shoves hello world into C, so I can look at what C is. It'll come back saying, hey, hello world. Probably one of the easiest programs to ever write, because I've never came across a case where you actually have to debug a hello world code. So logicals, basically just tests. So if, our example, I could say y, say it's like 7 times 6. And then, of course, I could say, x equals 42. And then I could say A is y equal to x. As is true. Of course, it works the same way too. Is x equal to y? Is y greater than x? All right. So basically, that's the general syntax. Is we are creating an object, and then we're putting something into the object. And then we can recall it just by giving the object name by itself. So generally, that's what you're going to see from now on, is we're going to create objects, we're going to do something to it, and then we're going to get a recall from it. All right, so some of the objects that we have, taking those base characters, logicals, numerics, taking those base and then applying it, we then get scalars, we get vectors, we get matrices, and then the big one that we get is data frames and lists, and that is really where R really becomes useful. Vectors, really simple. Essentially what you're doing is you're creating with a C command, and I'll give you a list of the little command shortcuts that come in handy. You're creating a big giant group of stuff. All right, so let's create a vector. Let's combine 1, 2, 3, 6, 7, and shift enter on that. If I recall A, gives me back what my list is. I can make references to it, so I can say A square bracket, say 0. And now we're going to say A square bracket 1. Now, if you notice, most programmers probably just recognize that indices in R begin with 1, just like similar to Fortran. Doesn't begin at 0, which is why when I asked it for A of 0, it gave me back nothing. We can shift stuff around as we need to later, but just to give you a generic heads up is whenever you fill up a vector and you're trying to do a recall on it, indices start at 1. And of course, you can have any kind of vector. You can have numeric, you can have characters, you can have logicals, and you can build them from there. All right, so matrices, really the big way of looking at it is just a multiple dimensional vector, all right? So except now we have cells, row names, and column names. And then we actually have data in there. And it works the same way. So I can generate a quick 5x4 numeric matrix. So I can do this. I'm just going to copy that over. And my mouse is not. There it goes. try that again. I lost my mouse. All right, so if I do that, I just created my Y, so I can look at what Y is. And now Y is a matrix, 5 rows, 4 columns, and it's taking the sequence 1 through 20 and it's putting that in there for me. We can also then create different stuff. So this is a little bit of a different example. What we're doing here is we're creating 3 vectors. We got cells, R names, and C names, and then we're taking all those together and we're building those into a matrix. So, all right, take a matrix built from cells. I'm going to say, all right, it's going to be number of rows, number of columns, and then where that data is coming from. And then, of course, recall works the same way. So if I want to recall some data from there, I just essentially say, hey, what's that a particular element? Or give me a specific column, or give me a specific row, or give me a section of a specific column and a specific row. Now, of course, you can then do multiple dimensional arrays, and these examples get kind of fun. I'll just talk about it real quick because the plotting stuff and the data stuff is really what you're interested in. So essentially what we're doing here is I'm creating a matrix A, and I'm saying, all right, fill it up with a bunch of 8s, and it's going to be 2 by 3. Hey, here's a matrix B, fill that in with a bunch of 9s, and it's also 2 by 3. And then, excuse me, there's Slack messages coming in. I go ahead and mute my phone. All right, so there's, then we're going to create another matrix filled with 9s, also 2 by 3. And now what we're going to do is I'm going to take an array. I'm going to go ahead and combine A and B together, and then how deep this thing's and what the shape of it's going to be. So, you know, from here we're going to be able to then extract our values and print everything out, and it kind of gives you this funky tree. But essentially what you're doing is you're taking multiple matrices, you're combining them together, and you're giving it depth. And then you're just, hey, these are going to be combined together into whatever, and now you can view your final matrix in place. All right, the other thing we have are lists. Lists are kind of handy. Essentially, if you have you need an object or a structure, a list is essentially where that comes into play at. So you can have everything related to each other. So you can have first name, last name, age, married, and put all that together and build a person structure with that, or a person object if you want, and then just access the different parts of that object. Data frames is where we really come into play. It's good to know because data frames, anytime in R you load a file or a data file in, it's going to come in as the data frame, which is great because R gives you a lot of cool tools to manipulate data frames. So essentially what a data frame is, it's a table. It's a table full of data. You know, it's a 2-dimensional table where the values you have basically row and column kind of data. Which means that we can read in a CSV file, or we can read in a matrix directly if you wanted to. Best way of manipulating that, if you do, let's just go ahead and pull this example in. Excuse me. So here I'm creating a vector D. All right. Then I'm creating a vector C. Okay. So now I can look at, oops, I'm combining those together. Oh, I'm sorry. I wanted those to go into E. All right, so now that's an E. And then I'm going to take this last one, which is just a bunch of true-false stuff, and I'm going to put that into F. So now we can combine those. I'm going to create my data, and we're going to pull those from, we're going to create a data frame. Data frame. And we're going to pull those from D, E, and F. Now, if I look at my data, it puts everything in. So we have D, E, and F. These are the vectors I just created. We then go ahead and put those inside of our data frame. So we have essentially our 4 rows and our 4 columns. And then, of course, we can now pull in certain things. We can change the names on them. So if I want to do something like this, so I'm going to say names. I'm going to give those things actually things to use. And now we can look at my data again. And now we actually have names instead of just those letters in there: ID, color, and past. All right, factors. So we can also, this is just, we have to go through the examples here, but factors are nice because you can now apply, if you have some sort of a Boolean value, a logical one, or A or B, you can go ahead and put those in the data set as well, and then you can get information out. So you can see, all right, we have X amount of males, X amount of females, and we want to be able to see, want to factor that data in, and it will go ahead and give us, we can then get summaries on that information or on that particular data set. We can do ordered factors as well. So if you want to be able to add weights, you can essentially do that. And then, of course, these are useful functions I was telling you about. This is a nice little cheat sheet. So we can say, all right, what's the number of lengths? I can say here, we can do length of D, and it will tell me, all right, so somewhere up there I had D, and it had a length of 4. We can also look at what the structure of an object is. So I can look at the structure of my data. And it'll tell you exactly what the essential basic structure of that object was. We can then do stuff like what we were doing before with the C, which is combining objects together to build a vector. C-bind essentially builds columns, R-binds builds rows. Object by itself prints the object out. And then LS is always a nice one too. LS prints out all the objects we have so far. So that notation is kind of fun. And then, of course, we have control structures. So this is essentially what an if statement looks like. If a logical value is true, we'll do one, else you can do the other. We also have, for loops. So essentially, this is looking at an index within a sequence. So I can create a sequence from 1 to 3, and I can just print something out real quick, and it'll go ahead and print out what the values are in there. But this is essentially how to do a for loop. We also have while loops. So while a condition is true, it'll continue running what's inside the loop. And of course, we can create vectors dynamically as well using a for loop. Just what we essentially do is you create an empty array, you put that in your object, and then you go through there you can go through there and replace parts of the object. Here I'm just saying, all right, there's a little condition that you're going to do replacement on, but essentially that's the meat of it, that assigns values inside the vector. And these are little fun things to do, just because if anybody's ever taken any beginning C++ or beginning programming class, one of the things you do a lot of is create the Fibonacci sequence. So this is actually really easy. All you say is, all right, I'm going to have length. I'm going to say it's going to be 10. That's how many values I want to see. I'm going to create this thing called fibs value. It's going to hold 10 numerics in it. And then you essentially just say, hey, the first element's going to be 1, second element's going to be 2, or second element's going to be 1. And then after that, 1 line of code, and you create your Fibonacci sequence. So I just do fib_vals. I created that object, and it creates the first 10 numbers of a Fibonacci sequence with 4 lines of code, 5 lines of code, versus I've seen my students take a horrendously amount of code to do that. And of course, something they're working on right now, which is building Pascal's Triangle. For those of you not familiar, Pascal's Triangle has a lot of cool features to it. It gives you the coefficients of an exponent. It also does it's got the Fibonacci sequence built into or hidden inside the soft diagonals. And it usually takes a little bit of work to get done. Oops, I don't think that copied everything I wanted to. All right, let's just take it up to there. All right, so there is the Fibonacci sequence. It looks like it all got through there all right. Oops, don't need the double assignment. or Pascal's Triangle. All right. So, so all I got to do is say Pascal. I created this object called Pascal Triangle. And if you look at the way this code is structured, it's taking a function. So if we're creating an object and we're piping a function into it, the function has a value h, and then h is essentially how many rows of Pascal's triangle I want to show. I'll do 10, 10, hit Shift Enter, and there's Pascal's triangle in about 6 lines of code. So you can do just with those basic things that we showed, the basic loop structure and the way objects are handled inside of R, you can do some really cool programming techniques. And actually, it's a very powerful language, being as simple as it really is. But what we're really interested in is we're really interested in data. Okay, so this is kind of tailored into our Jupyter instance that we have running on DesignSafe. So everything inside of your Jupyter instance is located inside of /home/Jupyter my data, and then if you have any folders or other stuff, they'd go inside there too. But essentially the name of your file and then the CSV is what we're using here. R does give you abilities to import in other data types as well. And then whether or not there's a header or what the row names are and whatnot. So essentially what they're separated with. But with this generic line, you should be able to read in most of your CSV files that you have. Everything that you're bringing into R, once again, is a data frame, so it makes it easy to manipulate. Some of the cool stuff it gives you as well, there are actually things that you can do to essentially do SQL-style querying. You can actually do kind of a ODBC connection to an R database and then be able to do SQL queries against it, which is kind of cool. I grew up doing SQL. Here's some example code if you want to see what some more integrated coding examples are. So you can kind of look at these and see what they do here. This one does distributions and marginal distributions through tables, which is kind of slick. This does efficiencies by looking at the mean values and median values. So, and the other thing, of course, R does is plotting. And the plotting part is actually what's really kind of slick. So first off, we're going to just look at some of the basic plot types. And we're just going to look at, so to do that, we're going to need to create a sequence. So what I'm going to do is I'm going to create a sequence. I'm going to create, whoops, I'm going to create X. And it's going to be a sequence from 0 to 2 pi. And steps of 0.01. All right, so there's my sequence of X. Y is just going to be equal to sine X. And so now if I just want to look at Y, all right, so there's the values of Y. Just to make sure X is good, I'm going to go look at the values of X. Yeah, X is going from 0 to 2 pi in steps of 0.01. So we have something we can graph. And of course, easy way to plot is you just have the word plot. What does you want to plot? I want to plot X and Y. I'm going to say type equals, and we're going to talk about this more in a little bit. And main, and just give it a name, sine curve. And there's our pretty little sine curve. So y-axis, x-axis, what the data is, and just a simple plot. All right, so now that we can do basic plotting and stuff, let's go ahead and pull in that data that we pulled in. A little hint is that seismic data, okay? So this is how we're gonna pull it in. We're gonna give it a name. I'm gonna call it W1. We're gonna say read.csv. I loaded it directly into my data. You might have put it into a folder or something, so just put that folder name in there. Once again, everything goes into my data, your notebooks, your data files. That has to be essentially where the root is. If you don't put it in my data, then when our servers get recycled, or when the time gets recycled on there, not the server itself, you're going to lose anything that's not inside the my data folder. So anything above that, anything in the home Jupyter folder is going to disappear. That's the one that we, so the CSV file we downloaded at the very beginning It came from the link here. Let me show you. If you go to DesignSafe, those of you who might have come in a little late, want to jump in and get that. If you go to DesignSafe.org, under our Learning Center, there is Training Resources. And then underneath the Training Resources, there is the Training Archive. And the Training Archive is where the data is for this particular class. I will also go ahead and pin that data to our Slack channel. Actually, let me go and do that now. So anyways, the data file is right here. CSV data file for Jupyter and R. We're just gonna use that same file and look at it a bit more. And let me go ahead and pull up Slack and pin that there. So go back to our webinar. And I'm gonna go ahead and go to Finder. There we go. And training data. And upload. And I'm going to go ahead and pin that file as well. And pin in this file. So then, of course, if you need to, just click download and it'll download the file. All right, so as soon as when that file gets loaded, what we're looking at is we have, actually we can get some information on it by just looking at what we have. Let's go back to our notebook here. And I need to load that file in. I haven't done that yet. So I'm just gonna go ahead and copy and paste that line in. W1 read.csv training data and shift enter. All right, so now I'm just going to hit W1 to see what we have, and it gives us this what the data file is and gives a quick little summary of it. Of course, we might want a little bit more summary than what we have, and R gives some really cool tools to do that. So I can do names, W1, and it'll give me all the column names inside there. I can do what the structure of it is. We just looked at that a little bit ago, but remember, everything inside of R is an object, and all the commands take objects. So I can just do an strw1, and it'll give me the structure of the data frame of the file we just brought in. And then, of course, we can do a summary as well. Okay, so now we have a little bit of summary information. It tells us, all right, we have 3 columns, PGA, call.res, exp brg long, and fxd brg long. All right, so what these are is these are some seismic data from, I believe, like 96 randomly generated bridge samples, okay? So what we're looking at is we're looking at ground motion around this bridge and on different displacements. So we have the expansion bearing longitudinal displacement, which is column 3, and the transverse displacement, which is column 4. Then we're looking at the curvature of the column, the curvature ductility, which I'm sorry, I'm not a seismologist. I'm not quite sure exactly what that does, but it gives you some pretty cool data to play with. So to get a little bit more information, we're going to add some columns to this. Adding columns is really actually very simple. Once again, we have an object. We're going to give it a column that we want to add to it, and then exactly how we're going to fill that information up. So what we're going to do is we're going to take that column data, W1. I'm going to give it a new column name. So I'm going to call it LN1. All right. And this is going to be the natural log. So when you do a log in R, just log by itself is a natural log. If you do log 10, that is log base 10. All right, so just log by itself, we're doing the natural log. And it's going to be an existing column, so I'm going to say column PGA. All right, so now if I do W1 or do a summary of W1 now, it should give me another column, LN1. Now I'm going to add another column as well. So we're going to add these natural logs of what the column data is, just so we have something, to correlate against, and we'll get some information from it. So I'm going to go ahead and add LNCR, which is going to be the curvature, the natural log of the curvature. And that's going to equal log W1 $sign call.res and W1 $sign LNEXP. It's going to equal the natural log of, I'm just going to copy and paste that. Oops, and I lost my W1 $sign LNEXP. All right, so now if I do a structure, W1 should have those new columns in there, LN1, CR, EXP, and FXD. So that'll give us something a little bit more fun to play with. All right, so the first thing we're going to jump into is basic plotting, okay? So essentially, I'm just going to look at some simple information. We're just going to look at a strip chart, which is the most basic type of plot available. All you're essentially doing is say, hey, let's plot strip chart, one of the columns. And in this case, I'm going to do LN1 instead of the example we have. LN1, just because it's faster to type. And there's our simple strip chart of how that information is distributed. Doesn't really give us too much information. Honestly, not that interesting to look at. You do see some pretty interesting exponential spacing that's going on with the data. Maybe it needs a little bit further digging into. So we can do a different type of strip chart. We can go ahead and stack that information. And so I'm going to go ahead and say a W1, LN1, and method equals stack. And now the information's stacked and how it's distributed. So now it's getting a little bit more information. So instead of all the points being multiple, now we're stacking the data on top of each other. So it's getting us a little bit more information coming out of there. We can also, instead of doing that, we can do I'll look at the jitter method instead. So now we can add a little bit more of a distribution. And we have a little bit better understanding of what the ground motion in G's is looking like, and show the natural log of it. And then, of course, we can do a little bit of fun stuff. So I'm going to go ahead and we're going to do some. Actually, I'm just go ahead and say we're going to go ahead and do a jitter on one and say vertical equals true. And oops, yeah, I want to do. Oops, that's what I want to do. That's what I want to do. And we're also just going to look at, we're going to combine the two together, and we'll do this. All right. So now we can get the two graphs going vertical instead. So we're now getting a little bit more what our accurate reading might look like. And then, of course, we can then do, we can add our x-axis, we can add labels to it and make the thing more interesting to add labels to our plot. And then, of course, the other things we also have are histograms. Histograms are basically just histogram it. What we're looking at, I'm going to look at W1, LN1 again. If I can type. So there's a histogram of it. So it gives you a little bit different information. And of course, once again, you can add using the main, you can add labels and x-axis labels to that too. And then, of course, you can also say how many breaks do you want. So I'm going to go ahead and say, you know what? Let's do breaks equals 8. And so, or breaks equal 6. And we're breaking it down, getting more information or less information, depending on how we want to look at it. And then, of course, the basic scatter plot that we did earlier. We can do the scatter plot again. And this is probably the most useful because this is essentially what we're going to be using to get some more information out of it that the basic plot may not give us. So let's look at ln1. Or W $1 ln $. I can't type today. And let's go against W1 XP. So now we have a scattered plot between the logarithm of the ground motion and our longitudinal, I believe, motion. So we got a little bit more information going in there now. And if we wanted to, we can then add our x-axis, our y-axis, and get some labels up there. Okay, so we're just about, so this is basically all the basic stuff that R gives us. And unfortunately, it doesn't tell us that much about what we're really looking at as far as the data goes. We can plot it, we can make sure there's data in there. We can see, all right, there's something of interest there. By looking at the picture, we know that the data is trying to tell us something, but we're not quite sure what that is yet. Luckily, what we have is we have this thing called ggplot. All right, so there's this new movement going on. Essentially what it is, the grammar of graphics is what this movement's kind of called. The basic idea is graphs should have the same basic structure that a sentence has, all right? So essentially what I want to do is I want to build a blank canvas. That blank canvas is going to be my object. And this is really where the power of R kind of comes into play at. So we want a blank canvas. And with that blank canvas, we want to give it some structure. We want to say exactly what this blank canvas is going to cover. And then we want to do is we want to plot some stuff in it, and we want to do some analysis stuff in it and ask some questions to it. This is where ggplot comes into play. Unfortunately, this ggplot is a different library, so we're going to need to load that library in. To do external libraries, we should have these already in Jupyter loaded. Just give it library and give it the name that we're looking for. ggplot2. All right, shift enter, so it loaded in just fine. Now, the other thing we want to do is we want to load in a data manipulation tool just because they'll be easier for us to play with. There's a tool called PLYR. There's a more data-focused one called DPLYR. All right, so that is essentially for data frames. It is actually kind of a powerful little tool to use in R, and it kind of combines stuff together. We're going to go ahead and pull that library in as well. This will give us some shortcuts that we can use to build our plots with. DPLYR, I'm going to go and load that. It's going to give you a little bit of an error, just a warning message. It's okay, everything's good. That should be a normal message you should see. All right. So the first thing we're going to do is we're going to create my plot. That's going to be our object. And what I'm going to do with it is I'm going to use the ggplot command and tell it what I want to graph. Well, I want to graph, and it might help if I'm not too quick with the shift button. I'm going to graph my data. W1 is where I have it loaded at. And the way this kind of works is I'm going to give it aesthetics. So the aesthetics is where you put in where it's going to pull it, what column it's going to be pulling its x-axis from, and what column is going to be pulling its y-axis from. So I'm going to do, actually it's not LNRPG, it's LN1. So that's a typo in my slides, I'm sorry about that, but it's LN1 is what we call it above. We can probably rename that if we want to. And oops, x is equal to, and y is equal to, and we're going to go back to that ln exp. So we're going to look at those two columns. And I'm just going to view my plot when it's done. All right. So what this should give us is a blank slate. So remember, the way that the ggplot, this grammar graphics works is first you want to build a blank canvas. This is our blank canvas that we're going to work against. What's really cool about ggplot is essentially what you want to do to it. You want to start adding geometries. This is basically what it is that you're going to plot on our blank canvas. And you literally add what it is you want to plot. So if I have my plot, if I just do my plot, and I want to take that object and I want to add my geometry points, that's all I'm going to do. Say, hey, take my plot and add geometry points to it. It should. Or not. Let's try that again. There's my plot loaded. Again, you're not wanting to do my geometric points. It's not erroring, so that's a good sign. I am doing ln1 and ln exp. Those should. Oh, you know what? I didn't add the aesthetics to it properly. So it is AES. I just had those two in there. So let's redo that. So there is my plot. There we go. Now it looks a lot better. So we have our x-axis and our y-axis, and it goes ahead and fills in what those are. Now that we have our axes in there, let's add in our geometrical points. There we go. So now we have essentially the same scatter plot that we had up here, just slightly different. So once again, we still see that there's a story being built in there somewhere, but we're still not quite sure what that story is. So really kind of what we want to do is we want to essentially add things a little different. And now what I'm going to do is I'm going to start building this into another object. So I'm going to call this my scatter. And this is where my scatter is going to be built from. It's going to be built from my plot plus geometrical points, because then I'm just going to start adding stuff to my scatter, and we'll keep on going from there. That way it's not going to be gigantic at the end of everything. All right, so I'm going to go and do that. So now we have my scatter, and let's look at it. All right, so there's our scatter plot again. Same scatter plot we had before. Like once again, we can kind of see there's something going on. We're not quite sure what it is, but ggplot, with some of the cool stuff it does, will tell us some of the cool things that we can do. We can add axes to it. I'm not going to bother with that. Labels and titles, you guys can kind of know how that works. Just essentially, we just give it a title with GG title, X label, and a Y label. If you notice, everything is added together. Once again, the way you build these things is you take your basic plot, basic object, and you literally add what it is you want to put onto it. So you want to add a title, we use GG title, then we add a X label and then a Y label, and we keep on going. All right, so next thing we're going to do is let's go ahead and add, I want to do something really kind of neat here, so we know there's something going on, so let's add a little bit of shapes to distinguish what the different values are that we're looking at. So I'm going to take my scatter, and this is where the joy of R comes into play at. So it's going to be my scatter plus our same geometrical points that we are playing with before, and I'm going to change the aesthetics on it. All right, and if there was a factor, meaning if there was like a male, female, or a list of items that we had that we can essentially build or query different items on, we can set colors to those different factors. Since this graph, we already kind of looked at the pictures, we don't have a factor on it, we can create one in R real easily by, let's say, if we just wanted to look at color, I'm going to have the color based on a different column. So we're going to look at column res. All right, now column res, I'm going to say every time, so I'm going to build the factor by saying, all right, where it's greater than the median and where it's less than the median. So I can use the median function. And once again, this is from W1 $, call.res is the name of my column. All right. And that breaks that off. And I'm also going to give it a different shape. And I'm going to have shape based on the exact same thing. So shape is going to be based on call res, and it also being greater than my median value of that column. So median W1 $, call.res, and make sure I'm closing my parentheses off properly. Should be 2, and the last one should be AES. All right, and then we're going to give it a size, and so we can see it. I'm going to set size equals 5, and close my parens off, and that should do it. And then I say my scatter because that's where I called it. And did I miss a parenthesis somewhere? My scatter plus geometric point, AES, color equals where my column, oh, I see, that needs to be W1. And shape is going to be W1 as well. And enter. So I got another typo in there. All right, now I'm on scatter. Call.res. Remote. All right. And I'm just going to go and let's just go to copy and paste this. I think I missed a parenthesis somewhere. Copy. And let's paste that in. All right, so let's look at my scatter again. And why aren't you loading? All right, I'm going to go ahead and pull in my example that I already wrote. And I was playing with it earlier and must have mistyped something here. All right, so color equals call res. Here's my line, geometrical points, size equals 5. All right. I must have mistyped something here. Go back into my other notebook. All right, so let's see what my scatter does now. It is not wanting to behave with me right now for some reason. So if I go back to my plot and then look at my scatter, it comes up with the data just fine. Now what I'm going to do is I'm going to look at, actually what I'm going to do, I'm going to go in here and let's clear my output. Okay, just because I want to make sure that I'm not messing this up by mistyping it. It's the joys of doing live demos. All right, so we're going to load our library in. We're going to load in our DPLYR library and look at our data again to make sure our data gets loaded properly. Here's all of our natural logs. I'm only going to mess with those last 2. All right, so we're going to look at our plot once again. So here's our blank canvas. Remember, the entire point of this is we take a blank canvas and we start adding stuff to it. So I'm going to create my scatter plot. So there's our scatter plot that we're talking about that we can definitely see. Once again, this is R. I can look at how a certain column is going against the median value of that column. And we can do this, whoops, Control Z. We can do the same thing with shape. So I'm gonna add some color and shape to our scatter plot, and hopefully it'll work this time. All right, so there is the same data set we're looking at, but now we're looking at a circle where our column res is greater than the median, and we're looking at a triangle where looking at a circle where it's less than the median value and a triangle where it's greater than the median value. So we get this plot. So now it's starting to come into a little bit more focus. And just as we see what the median value is 0.285. All right, so the next thing what we want to do is we're going to see if we can add a little bit more of a lowest line with a 95% confidence interval. All right, so to do that, essentially we're creating a new plot here. I'm going to add the geom smooth option to it. So with the geom smooth, we get this. So now we can essentially see how our data, where our data, what it lies inside of. And if we wanted to, we can also add a simple regression line. So to do that, I'm going to say, all right, my scatter, LM, so I'm going to give it a new value here, is going to equal my scatter is, and I'm adding a geom smooth, and I'm saying method equals LM. So with that, we get this. So now here's our regression line, and we can see where our data is sitting from one to the other. So we're starting to see where the interest lies now. Where is the data most interesting, and what does that actually mean? All right, so we can add a little bit more. We can group our data together. So once again, I'm going to group the data on that same column res, where it's greater than our median value of the column. And I'm going to run that. So now our data is grouped. So now you can see the two different groups of data and the two regression lines on those two groups. It's still not quite clear to us. So then what we can do is we can add a little bit of color. So what I'm going to do is we're adding, I'll go to the next slide here is where essentially we're doing it. We're going to add color to our regression. So I'm going to say the color is going to be the same thing. We're just looking at that median line, and we're going to fill it depending on where it sits inside there. And so now we get this. And this gives us a lot more information about that exact same scatter, the basic scatter plot that we first saw in our other trail. That one versus what we're looking at now. We have information that actually kind of makes sense, where we can actually get a story out of understanding what that story is, which is basically what that data set is. And our entire data set is, and by the way, I'm going to suggest ggplot is a very powerful tool. This was just kind of an introduction to you. These are things that would take a lot of coding to do using the basic plot routines that R provides. We're able to do some really cool things by just adding certain aesthetic types to it, certain geometrical methods to it. And in doing so, we're essentially finding out what that story is. So I used to be a database guy. So being a data guy, there's always a story inside your data. The idea is you're looking at all these numbers in front of you. You got to figure out what that story is. So what R does is R gives you the tools to be able to look through a data set and see what that story could be, find that underlying story. So a little bit of summary of what we did. We looked at some basic R commands, what the basic structure is. With just that basic structure, we're able to build and read in a data frame. And once again, use that same structure and the same syntax, we're able to plot our data and get a little bit of general analysis on what that data might look like and what that data actually means. And of course, we're essentially just grazing the surface. What we plan on doing is our next, we'll probably do another series in this webinar with R, where we will dig into a lot more of what ggplot does for us when we have a little bit more time on our hands. But for now, I think this probably gives you a good idea of what you can do with R, what you can do with Jupyter, and what you can do with DesignSafe. So the idea is you load these data sets into DesignSafe. Then you use a Jupyter, or you use Jupyter to then, using R or Python, in our case R, to basically dig through that data and see what you find out, see where the interesting relation points are, and be able to plot those and have that story come out to you a little bit more. All right, so if you guys have any questions, feel free to hit us up on the Slack channel. You can also email us at training@designsafe-ci.org, or you can fill out a ticket. If you go to Design Safe Help Tickets, fill out a ticket for us if you have any questions. These notebooks are going to be, I'm going to download those and then share those on our Slack channel as well. And so you guys can go ahead and upload those to your DesignSafe My Data and be able to play with those if you weren't able to get everything copied in. I do suggest, I do have some links here, some more R tutorials, the references I used, and a lot more information regarding what the ggplots can do for you. I do suggest you look through that. ggplots is actually a really cool little cool tool and gives you a lot of plotting capabilities that R doesn't give you out of the box. All right, with that, I'll leave the chat window open here for a little bit. Feel free to ask some questions. Feel free to jump onto the Slack channel and we can continue the discussion there. And of course, the discussion doesn't have to end on the Slack channel. It can continue on as long as you need it to go. And thank you very much. I really do appreciate your time. There will be another DesignSafe webinar at the end of next month where we will essentially take you through Jupyter and OpenSeas and give you a live demo on that. And then coming up after that, we'll have an introduction to scientific visualization and DesignSafe. All right, thanks for your time, guys. I appreciate it.